This is Math 3 1.2b Notes, and it's titled Quadratic and Exponential Functions. Please be sure to put your name and period here so when you take a picture and send it in, it's easy for me to see. Okay, what we're doing here is we're going to graph, given the given function, graph the given function and state the domain and range in interval notation. Okay, key point there is they asked for it in interval notation. Okay. So we've gone over interval notation in notes and in class, so I'm hoping we have a little more practice with it. Okay, so what do we do? Remembering from Math 2, I'm going to put a little arrow here. Actually, nope, we can fit it in here. This piece here told us to move left or right, and the last number at the end told us how far to move up or down. Okay, the inside number was left, right. The outside number was up, down. Opposite of the inside, the outside stays the same, is the way I've taught it to Math 2 kids in the past. So it's +2, so I'm going to go left 2 because it's opposite. And then it's -3, and I'm going to go down 3 because it's the same. 1, 2, 3, and I'm going to put a dot right there. Okay, so we're graphing just as we've graphed the last few days, but now with translations. Left 2, down 3. Left 2, down 3. Left 2, down 3. And then from there, remember, we need 3 lattice points. So how do I get my other points? First off, I recognize because it's squared, it's a quadratic, which means it's going to be a U shape. It's negative, so it's going to be opening down. And I cannot do more than one set, but I can do at least one set using this. So down 1/2 over 1, back to my start point, down 1/2 over 1. Now, because this is not linear, I cannot go again down 1/2 over 1. Only one set, down and over, and connect. And make sure you make it a U shape, not a V shape, because it is not absolute value. Okay, today we're only graphing the parabolas, the quadratics, and exponentials. We're saving the other graphs for another day. Okay, that's it for the graph, domain, and range. All right, if you remember from Math 2, domain was always all rails for parabolas unless there were any restrictions. There's no restrictions. It's going right forever, left forever. So our domain is still all rails, but we write it like this, -infinity to infinity, because it goes rightward and leftward forever and ever and ever. Off in the big picture, it gets really, really big, wider and wider and wider and wider forever. So that's how it works. All right, range. It's not -infinity to infinity because the graph does not go up and down forever. It goes only down forever. So we say, starting from the bottom, you always go bottom up for your range and left to right for your domain. So coming from the bottom, 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 there's always a graph at the bottom because the arrows tell me it's going down forever. So -infinity. And it doesn't go up forever. It stops at what y value? -3. 1, 2, -3. Okay, so my range is from -infinity because the arrows tell me it's going down forever. So it's -infinity, and then it stops at -3. And parentheses always on the infinities, and -3 has a bracket because that's not an open circle, so it's included. All right, next one. Another parabola, it's another quadratic. Now, there is nothing in parentheses. Think of it this way. Now, you don't have to rewrite it that way every time, but at least mentally picture this. Because there's nothing in the parentheses, that means I'm not going to move right and left, but I am going to move down 1. So I'm not going to move right or left, but I'm going to move down 1. And that's my start point. Why did I move down 1? Because that's -1. Why did I not move right or left? Because there was nothing inside the parentheses here, like there was over here. Okay, and then I use my A value, which is +1, and it's positive, so I'm going to go up 1 over 1, back to my start, up 1 over 1. I can't do it again because it's not a straight line, it is a curve, and I go from there. Okay, next two are exponential, a little bit harder, so you want to make sure you are paying attention. Okay, the concept stays the same. This is going to be right, left, this is going to be up, down. So it says minus 2 there, so it's going to be right 2 and then up 1. And I'm going to come back over here because I forgot my domain and range. Please don't forget that on your assignment, domain, range. Okay, like I said earlier, because it's a parabola and there's no restriction, the domain's always going to be negative infinity to infinity, all real numbers. It goes right forever, it goes left forever, negative infinity to infinity. The range, I come from the bottom, and I don't put negative infinity on this one because it's not going downward forever. The very first y value I have is -1, and then it goes up forever, so then I put the infinity. And brackets on the -1 because there's not an open circle. Okay? All right, so we said right 2, up 1. Be careful. Kids will start at 0, 0 and go right 2, up 1. Remember, this is a special one because it's exponential. The start point, the original start point is at 0, 1. I'm going to erase that. I'm just putting it lightly. This is my original start point, and from here I'm going to move right 2, up 1. Okay, so from my start point that I just erased, which was 0, 1, my original start point, I went right 2, up 1. Now remember, the asymptote is always 1 below the start point, so this is my new asymptote here. And the asymptote will always be 1 below the start point, wherever your start point is. If my start point was over here, I would go 1 below and make the asymptote. Okay, now how do we figure out our next lattice points? You need 3 of them. See how I have 1, 2, 3, 1, 2, 3, 1. This dotted line I will count as 1, so you already have 2. You need 1 more. And here's what you do. Before, we'd go back to the origin. So this is my fake origin. Go back to the dotted line from your start point. Go back to the dotted line and go up 3 over 1. 1, 2, 3 over 1. I'm going to repeat that. From my start point, I go down to the dotted line, and then I go up 3 over 1. 1, 2, 3 over 1. And I have 3 lattice points. That start point, the one I just counted, and my dotted line counts as 1, my asymptote. And then you make your nice and pretty graph. Okay, now I'm going to do a quick check just to make sure that it's working out properly and we're not doing anything crazy here. I'm going to check these 2 points mathematically and see if it works out. 1, 2, an x value of 2. Plug it in. 2 minus 2 is 0. 3 raised to the 0 plus 1. 3 raised to the 0 is 1, and 1 plus 1 is 2. And sure enough, there it is. 1, 2, I'm sorry, over 2, up 2, that's that point there, 2, 2. Next, what I'm going to plug in, we're hoping to get, let's see, 1, 2, 3, 1, 2, 3, 4. So let's see if we get 4. Plug in 3. 3 minus 2 is 1. So I have 3 to the first plus 1. 3 to the first is 3, plus 1 is 4. Indeed, they both check. Again, this was just our check work to see if we did everything correctly, and we did. Okay, domain. Now, it doesn't look like the parabola, but it's still going left forever and right forever. So it's still negative infinity to infinity. Now, on the right side, it looks like it's going up. It is, but it's not ever going straight up. It doesn't ever end up being vertical. It gradually, ever so slightly keeps getting like way off to infinity. It's getting further and further out to the right. Very slowly, but still getting there. So negative infinity to infinity. All right, coming from the bottom, there's no graph, no graph, no graph, no graph. Now, it gets really close to this dotted line, but never it's going to touch, and that line, that x value is -1. And then it goes up forever. And on the -1, I'm going to put parentheses, not brackets. The reason I'm not going to put brackets is because it's never going to touch, and sorry, that should be a +1. It's never going to touch the +1. Okay, I'm going to repeat that because I was off screen and I had to fix it. Okay, why do I put 1 to infinity, and why do I put parentheses on the 1? Because this is the value. This red line is the 1, and it's never going to touch it, but it's going to get really close. So I put the 1 there because it's going to get close, but I put parentheses because it's never going to include it. It's just going to get close to it. and then it goes up forever, so I put the infinity. We will discuss these more in class, so don't freak out like, oh my goodness, what is going on? That is okay. This is new concepts. These are new concepts. So it's okay if you stress a little bit. We will clear some up in class. Okay, next one. Y equals 2 to the x minus 4. And there's nothing in the parentheses, so I'm not going to move right or left, but I'm going to go down 4. There's nothing in the parentheses, so no right and left, but I'm going to go down 4. 1, 2, 3, 4. That's my new start. And there's a mistake I just made. Think about what it was. And I'm hoping you realize it. It's what I said earlier. A lot of kids will start at the origin and go down 1, 2, 3, 4. But remember, exponential is a special case. The start is 0, 1. I'm going to put it lightly there. And then you go down 4. 1, 2, 3, 4. So that's my new start, which happens to be at negative 3. Okay, I'm going to erase that. And remember, 1 below is always your ... All right, and first lattice point, the asymptote counts as a second lattice point. The next one, from my dot, I go down to the fake origin, and from here I'm going to go right there, that's a 2, up 2 over 1. Okay, and I'm going to graph and domain negative infinity to infinity, because I'm going left and right forever. Range, the lowest I get is 1, 2, 3, negative 4. I never hit the negative 4, but I get really close. So I'm going to put parentheses, comma, and then I go up to infinity forever. All right, and again, I will clarify some of these in class. Okay, next one. I am going to have you guys put a nice big beautiful star right in here for me. So put a star right in there. And just do it. I'll explain another day. You're putting a star right in between 5 and 6. Okay. Whew. Number 5. Write the equation of the function using the indicated points. All right. I didn't give the points. I'm sorry. I didn't give the graph yet, but I'm going to graph it for you now. And on your work and on test and quizzes, when you're doing these type of problems, the graph will already be given to you. You don't have to graph it. We're going to graph it here, though. We're going to go right 2 down 1. You're going to go right 4 up 5. And we're going to make a parabola. Oh. All right, so you're making your U shape. And because I want it symmetrical, I'm just going to count over 1, 2, and put that dot. Don't worry about how I got the dot on the left, because the graph will be given to you. Okay, so imagine this beautiful graph with these 2 dots darkened in. Now, those dots are not going to be labeled for you, so I would suggest you label them on your own. So even though they're not labeled, we're going to label that was 1, 2, comma, negative 1. Again, that won't be, they'll be plotted for you, but you have to go through and label them. And this was 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. Sure enough, it's 4, 5. All right, how do we come up with the equation? Now here, remember from Math 2, your teachers taught you this: y equals a times the quantity of x minus h squared plus k. And do not say no, they didn't, because they did. This is what you guys were doing right before the COVID-19 happened and we did all the shelter in place and everybody left. This was the concept you guys were covering. Okay, so the number in the front determines how wide or narrow. The h is the right, left, and the k is the up, down. Okay, so because this is a quadratic, the original start is 0, 0, and from 0, 0, it looks like I went right 2 and down 1. Right 2 and down 1. Y equals, I'm going to put, if you're working in a pen, don't write this down because we are going to erase it. A parentheses, x right 2 would be minus 2, close parentheses squared, and then down 1 would be minus 1. Okay, so if you're working in pen, write everything except the a, because that's what I'm going to go back and erase. Everything else is going to stay. The x minus 2 squared is going to stay, and the minus 1. Now think about it. If I gave you this, just ignore the a for now, and I said, where would your start point be? You would say right 2, down 1. Opposite of the inside, outside stays the same. From the origin, right 2, down 1 is indeed the start point. Okay? How do we find the a value? You use the point given to you. The other point, there's going to be always an extra point, and that extra point is 4, 5. And what we're going to do is plug it in for x and y. So for y, I'm going to plug in 5. A, I don't know. I am going to move this up so I do not run out of room. All right, so point is 4, 5. And I'm going to have 5 equals a, I don't know, x is 4 minus 2 squared minus 1. Okay, so I plugged in 5 because that was the y value. And I plugged in 4 for the x value. Okay, now I am going to clean things up. 5 equals a, 4 minus 2 is 2 squared minus 1. Still not done cleaning up. 2 squared is 4, so I have 4a minus 1. And now that's a simple two-step equation. Add your 1 to the other side. 5 plus 1 is 6 equals 4a. Divide both sides by 4 and reduce. Divide top and bottom by 2, you get 3 over 2 as your a value, and you are ready to plug it right back in there. So now, like I said, I'm going to erase that and put it in. There we go. Y equals 3/2 times the quantity of x minus 2 squared minus 1. If you had a graphing calculator or a graphing app on your phone or on your computer, you can plug this in and it would give you a graph looking like that. A little nicer because mine is hand-drawn. Okay, I am going to stop here. I will do these two with you in class. Now, of course, when you turn them in, you won't have these two done at all because I didn't give you the graphs. But I will do them with you in class. So when you turn this in, you should have all the front page done and number 5 done. All right, and then I'll finish this with you in class. That is it for this lesson.